Coordinate geometry. In this subtopic is straight lines. So video number 5. Yesterday previous class discussed various forms of straight lines. So in this first one is y equal to mx. Second one is y equal to mx plus c. Third one is y minus y1 equal to m into x minus x1. Fourth one is y minus y1 equal to m is y2 minus y1 by x2 minus x1 into x minus x1. Fifth one is x by a plus y by b equal to 1. So these are the various forms of the straight line. This is the y equal to mx. This is slope. This is slope intercept form. This is slope form. This is slope and point form. This is 2-point form. This is intercept form. So this is the y equal mx line passing through the origin. This is slope passing through the origin having y-intercept equal to c. This is slope and point. This is 2-point form. This is x-intercept is a, y-intercept is b. Parallelism and perpendicularity of lines. Parallelism and perpendicularity of lines. Suppose in this coordinate system, this is x-axis, this is y-axis, this is origin. Now these two lines are passing through like this. So this is L1, this is L2. Here inclination is alpha, this is beta. So alpha and beta are the inclinations of the two lines L1 and L2. So in this alpha equal to beta, then slope of line L1 equal to tan alpha, slope of line L2 equal to m1 equal to m2. So that implies tan alpha means m1 equal to m2. So m1 equal to m2 means slopes are equal. So these two lines are parallel. So here L1 is parallel to L2. Then if two lines are parallel, then inclination of L1 equal inclination of L2. Then tan alpha equal to tan beta. This is gradient form. So m1 equal to m2. So two lines are parallel, then slopes are equal. Here note, if two lines are parallel, then their slopes are equal. This is the condition for parallelism. That implies, that is two lines are parallel means L1 is parallel to L2. That implies their slopes are equal means slope equal M1 equal to M2. M1 equal to M2. Conversely, if M1 equal to M2, then L1 is parallel to L2. So if slopes are equal, then automatically lines are parallel to each other. This is the condition for parallelism. So now perpendicularity of lines. So this is coordinate system. In this coordinate system, we have to draw the two lines like that. This is one line. This is another line. This is L1. This is L2. So this is angle. This is one angle. This is 90. This is 90. This is beta. This is alpha. So here L1 is perpendicular to L2. That's why make angle of 90 degrees. Here this is alpha is the beta. This is beta is the exterior angle. Alpha is the interior angle. So by exterior angle property, beta equal to alpha plus 90 degrees. Alpha plus 90 degrees. So taking tan on both sides, tan beta equal to tan of alpha plus 90. Tan of alpha plus 90. So here 90 plus alpha. Tan of 90 plus alpha or alpha plus 90. That equal to 90 plus alpha means here minus cot alpha. So here cot alpha means here M1 equal to tan alpha equal to M1, tan beta equal to M2. So now here cot alpha means minus M1. That equal to here tan beta equal to M2. M2 equal to here we can convert this here 1 by minus 1 by tan alpha. M2 equal to minus 1 by M1. Minus 1 by cross multiplication M1 into M2 equal to minus 1. This is the condition for two lines are perpendicular. The product of two slopes equal to minus 1. Then two lines are perpendicular. So here already given that L1 is perpendicular to L2. Then L1 is perpendicular to L2. Then the product of their slopes M1 into M2 equal to minus 1. Conversely, if M1 into M2 equal to, if M1 into M2 equal to minus 1, then L1 is perpendicular to L2. This is the condition for perpendicularity of two lines L1 and L2. Angle between two lines. So here in this coordinate system, x-axis, y-axis, origin. Now we can draw two lines like that. Here this is L1, this is L2. Now this is L1 making angle of alpha. This one angle of beta. L2 is beta. So slope of L1 equal to M1 and the slope of L2 equal to M2. Then distance angle between two lines equal to tan theta equal to M2 minus M1 by 1 plus M1 into M2 modulus of M1 plus tan theta equal to this is the angle between tan theta equal to M2 minus M1 by 1 plus M1 M2. So in place of theta we have to take here alpha. place of theta we have taken alpha, tan alpha equal to m2 minus m1 by 1 plus m1 m2. So here if theta is acute, then beta is obtuse. If alpha is acute, then beta is obtuse. If alpha is obtuse angle, then beta is acute angle. Why? Because sum of two angles equal to 180 degrees. Alpha plus beta equal to 180 degrees. That's why. So linear plane. That's why we have to take tan alpha equal to positive. Then beta equal to alpha is acute and beta is equal to acute. Alpha is obtuse, then beta is acute. This is the angle between two lines L1 L2 equal to tan alpha equal to m2 modulus of m2 minus m1 by m plus m2. Here condition is 1 plus m1 is not equal to 0.